Hey physiology students, welcome back to the lab. Today we're going to do respiratory lab with a spirometer, and we're going to get a normal spirometry reading like you would in any hospital. Okay, we have our Lager Pro sensor again, and we have a spirometer, this device right here. Connected to it, this plastic piece is a bacteriological filter, and then I've got a disposable cardboard mouthpiece. So what we're going to do is we're going to take a normal spirometry reading and find out what lung volumes are, and then we're going to do a couple of respiratory challenges. So let's look at the computer. Okay, so we're going to start data collection. I'm going to breathe into the cardboard mouthpiece, and it's going to show the volumes that I'm moving with my lungs. So let's begin. I'm going to take 4 tidal breaths, then I'm going to inhale deeply, exhale deeply, and take a few more tidal breaths. Okay, we're done. Now we're going to have to analyze the data. Okay, so now we're going to measure the lung volumes, and what I'm going to have to do is I want to measure my tidal volume. So to get a tidal volume, these 4 waves right here were a normal in and out breathing without effort. To get the tidal volume, I put the cursor at the peak of one of those and I drag it down to the trough, the bottom, and you look at what the delta Y reading is. Okay, now to find my inspiratory reserve, I'm going to put my cursor at the top of one of my tidal inhalations. I'm going to drag it to the top of that big inhalation. I'm going to look at the delta Y again. Okay, good. Now to get my expiratory reserve, I'm going to go from the base of one of my tidal volumes, and I'm going to go to the base of that big one right there and look at my delta Y. Okay, now in your handout you're going to learn how to use those 3 values to calculate vital capacity, total lung volume, and so that's going to be a question you have to answer on your questionnaire. For the hypoventilation or breath holding experiment, I'm going to have to calculate minute ventilation before I held my breath and minute ventilation after to see if there was a change. So to collect my data, I need to know my tidal volume before, so I grab from the top of that peak to the bottom and I look at what my delta Y is. Now I want to know the respiratory rate. So I'm going to go from one peak to a neighboring peak, and I'm going to look at the delta T. All right, now if you multiply those 2 numbers together, that will give you your minute ventilation. Now I'm going to go to after the challenge. This is where I held my breath, and over here I'm going to get my tidal volume from peak to trough here. I'm going to look at my delta Y, that's volume. Then I'm going to get my respiratory rate by going from one peak to a neighboring peak. Okay, and now I look at my delta T. If I multiply those 2 values together, I will have my minute ventilation after the challenge. Okay, this is the data collection from the hyperventilation or a rapid breathing experiment where I took about 4 normal tidal breaths. I rapidly breathed for about 40 seconds, and then I took about 4 or 5, maybe 6 tidal volume breaths after that. Now to get our data, we're going to have to do what we did in the previous experiment. We're going to have to go from peak to trough of a tidal breath before, and we're going to have to record that delta Y. Write it down. Okay. All right, and now we're going to have to get the respiratory rate. We'll go from peak to a neighboring peak, and we're going to have to look at the delta T. Okay, write that down. And when you multiply those two numbers together, you get minute ventilation. Okay, now we go after the respiratory challenge, and I'll go to one of these tidal volumes, and from peak to trough, I'm going to record that delta Y. Write it down. And then to get the respiratory rate, I'm going to go from peak to a neighboring peak and record the delta T. Okay, write that down. Now if you multiply those two numbers again, you'll get your minute ventilation after. So we want to know what happened to minute ventilation. And you're going to have to answer that and explain the physiology of why that happened.